Now, today we want to discuss about the atomic structure. Not waiting. Atomic structure. In atomic structure, what we have want to discuss first, discovery of the electron in cathode rays experiment. After that, we have to discuss proton. After that, neutron. Next, Rutherford atomic model, that is alpha particle scattering experiment. Next వచ్చేసి Bohr's atomic theory. After that, we have to discuss Heisenberg uncertainty principle, photoelectric effect, Planck quantum theory. Next, different Pauli's exclusion principle, quantum numbers, Hund's maximum rule, Pauli exclusion principle, and Aufbau principle. These are the topics we have to discuss in the atomic structure. We want to discuss. First, we have to discuss about the discovery of the electron. Who has discovered this electron? In up to 18th century, Dalton has told the smallest particle exists in the universe is atom. After that, one of the famous scientist J.J. Thomson, he has did the cathode rays experiment, discharge tube cathode rays experiment. He has find out the electron. What is the discharge tube cathode rays? That is called it as discharge tube cathode rays experiment. He has did it from then he has find out the electron. First, I want to explain what is the experiment. After that, the properties of the cathode rays. What are the properties? These properties, after this properties shows this electron, he has named it as cathode rays as electron. How he has discharged, what is the mass of the electron, how he has find out what is the charge of the electron, and how to learn this from this chapter. First, we have to discuss about the cathode rays tube. He has taken two electrodes. This is one of the electron cathode. We call it as cathode. Take another electrode. It is positive terminal. This is anode. These two are put in one of the discharge tube. This is called as a discharge tube. These electrode terminals are connected with electric circuit. Okay. Next, here whatever the unwanted gas, we have to, from this vacuum, we have to remove it, and at the anode side you have to put it one of the screen, that is zinc sulfide screen. By supplying 1000 volts electricity, by putting this is very low pressure, 10 power minus 3 mm pressure, means it is vacuum only. By putting any gas by this low temperature, this much of 1000 volts, by supplying electricity, some of the rays travel from this cathode towards anode side. Today this is perforated, means gaps are there. They will travel from this cathode electrode towards anode side. He has observed that these rays comes from this side and they will strike this screen also. We identify this at this screen by supplying this much of 1000 volts electricity and a very low pressure. He has observed that some of the rays comes from this cathode towards anode side. due to this perforated anode, they travel from through anode. Also, he has strike this zinc sulfide skin. We observed here. These are called as these rays. Name it as cathode rays. These particle rays names is called cathode rays. What we have observed here, what features these cathode rays will have? First, these are having, one of the first is, these are having possesses negatively charged. First, these are having negatively charged. Second one, why negatively charged? They will travel towards the positive. That's why these are having negative charge. These are having possesses straight line. They travel to straight line. Why? Because if you put any opaque object, they will form here image. Means opaque object, after striking this opaque object, you put here any opaque object, they will form image. Means they will not, opaque object means it will not allow the any rays. They will form the other side image. That's why this is called as a having straight line. Next, these are having possesses kinetic energy. Kinetic energy means we put any paddle here. After striking these rays, they will rotate it. Means they are having particle nature. These are having kinetic energy and also having particle nature. Fifth one, if you put any electric field here, electric field means negative, positive. These rays are deflected towards the positive side. That's why these are having towards, in the case of electric field, they are deflected towards the positive side. Positive electric fields. And also we put the magnetic field. Any charged particle, in case of we apply magnetic side, is always it will deflected. In case of these are the, this is we discussed in case of physics, left thumb rule, Flamingo left thumb rule. There we will discuss. But any charged object, charged particle, we put in the magnetic field, it will always deflected. Next, they will form the fluorescence material here, fluorescence here. Next, sixth one, if you change this electrode or we put any gas here, they will not change this. These cathode rays does not depends upon the, by putting any gas material here, different gas, or by changing this electrode. These the properties of this cathode rays does not change, means does not depend. He has did one of the experiment, that is E by M, charge per mass ratio. They will find out, he will find out one of the constant, that is 1.75 into, that is 1.75 to 10 power minus 11 coulomb per kg. In by putting different gas, different electrode, this is remains same, means this is remains same, means that does not depends upon the properties of the cathode rays on by changing electrode, by putting different gas. These are the one of the observation he has observed by J.J. Thomson. That's why these rays are called cathode rays. These are the fundamental particles. That's why this is name it as electron. Yes. Next. What are the features we have observed in the cathode rays? First, we have observed these are the features of the cathode rays. These are the negatively charged. These are the negatively charged. Second observation he has noted, these are travel through straight line. These are travel to straight line. Third observation, these are having kinetic energy. These are having kinetic energy. Fourth one, these are possesses particle nature. Fifth one, these are deflected towards electric field, towards deflected towards positive electric field. These are deflected towards positive electric field, and also magnetic field. One of the main feature about this one is, this is very important. How to note down. One of the important object is, these cathode rays does not depends upon nature of the gas and electrode material. This is one of the important points you have to remember. The cathode rays does not depends upon nature of the gas and electrode material. How he has find out? J.J. Thomson here did a E by M, charge per mass experiment. He has find out 1.75 into 10 power minus 11 coulomb per kg. He has constant, he has, by using different gas, different electrode material, he has getting one of the constant, that is 1.75 into 10 power minus 11 coulomb per charge, same constant. Then these are the some of the important features in case of cathode ray experiment. He has find out the electron. This fundamental particle is called electron. Fundamental particle is, why is fundamental particle? This is does not depends upon any gas or any electron. That's why this is called this is electron. This is named it as a electron. In case of Millikan has did a oil drop experiment. That is Millikan oil drop experiment. So Millikan oil drop experiment, he has find out charge of the electron. Charge of the electron is equal to 1.625 into 10 to the power of minus 19 coulombs. 1.602 into 10 power minus 19. This is charge of the electron. We know charge of the electron and also charge by mass ratio. After that we find out the mass of the electron is equal to 9.1 into 10 power minus 31 kg. This you have to remember, 9.1 into 10 power minus 31 kgs. Millikan has find out the charge of the electron. Charge per mass ratio, he has find out the J.J. Thomson 1.75 into 10 power minus 11 charge per coulomb per kg. From by using these two, we have to find out the mass of the electron, that is 9.1 into 10 power minus 31 kgs. This you have to remember cathode rays experiment. After that, next we have did that is after the electron, we have to find out one more important topic, that is how to find out the proton. In atom, only negative charge cannot exist. If it is negative charge, means there it is always being one of the, if you want to atom neutral, have to there always positive charge. Goldstein, one of the scientists, Goldstein, he has did the one more experiment to find out the proton. He has did the same like this experiment. How he has find out the proton. Same like that, he has cathode rays, he has taken one more cathode, this is positive terminal, anode, he has observed one more, this is cathode, and also this is, we take one of the discharge tube by putting the electric current, to take vacuum here. Here we put the one of the fluorescent material here, that is in case of zinc sulfide here, like the same have to here put it here. Next, in that case we have cathode rays 10 power minus 3 mm of pressure we have applied. Here we have observed 10 minus 1 mm pressure, 1000 volts of electric current. In this case by putting gas, what you have observed, these are the positive ions, they move towards the anode, cathode side, not anode, cathode side. Means by applying smaller pressure also he travels anode, these rays are called anode rays. He has observed they moves towards the cathode side, means these rays are called, he has named it as anode rays. If you take in this case by changing the gas, the material from this electron towards the positive side, these positive ions moves towards the cathode side. If you take different gas, it will, these rays are changes from the cathode, traveling from towards the cathode side. If you take in case of hydrogen, this is having negative, this is having positive, this is more moves towards the cathode side. By putting by find out the E by M charge, highest, if you want to find out the highest charge by mass ratio, means mass is very low, that gas will having the highest in charge per mass ratio, travel towards the anode side, cathode side. Those atom, those gas is name it as these name it as proton. These gas, these particle, charged gaseous particle is name it as proton. 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 In this case, what we have observed, in this case, this is also having all the character features of the cathode rays, but these are depends upon nature of the gas. Nature of the gas. If you change the gas molecule, the rays will be changes. This is mainly depends upon the nature of the gas, but those particles are not depends upon the nature of the gas. Okay. One of the main key feature of this, in this case of find out the proton, then charge of the proton we discussed here, 1.602 into 10 power minus 19 coulombs, 1.625 into 10 to the power of 1.6 into 10 power minus 19 coulombs. Then in case of mass of the electron, 1.625 into 10 power minus 27 kgs. This is mass of the proton. Mass of the electron is equal to 9.1 into 10 power minus 31 kgs. Mass of the proton is equal to 1.625 into 10 power minus 27 kgs. Mass of the proton is 1837 times heavier than electron. Mass of the proton is 1837 times is heavier than electron. This means so far we have discussed only electron and proton. Neutron we have not discovered. If you observe here, mass of the proton, mass of the electron, mass of the proton is 1837, not equal. These are 1837 times heavier than mass of the electron. Means if these are not neutral, this is having positive charge, this is having negative charge, but mass is not equal. Means after the discovery of these electron and proton, some of the scientist has find out means some other particle maybe will be there. After the discovery of these electron and proton, again they are scientists are working on that. They will find out the particles of neutron that will be discussed after this class. Thank you.